Alright guys, welcome back. So today we're going to do part 2 of our generative maps tutorial. This is going to be using Replicator the Replicator COMP to create some map layers that are going to let us do some pretty cool things. The most obvious being have the coloration differ based on, let's call it country or geographic area. As well as have these kind of self-contained paths inside of each geographic area, and some other stuff that is not visible at the moment. So, this is right where we finished our last tutorial, and so I'm going to start from here by first deleting all of this and ending with our edge right here. All right, so what we're going to do at a high level, is try to create something that's going to let us take our raw noise, all right, there we go. Take our raw noise and slice and dice it to extract different layers. In this case, to form these kind of different country formations. And then within each of those layers, we will create some boundaries, pass it into a jump flood algorithm, and then have a fully textured layer, including these jump flood lines, which look a lot like roads or streams or something, but I think roads, to appear and be self-contained within each of the different geographical areas. So, how to do that? First, we're going to create a component, and this component is going to be basically our master for our replicator. So first we have to get one working, and then we can create a template out of it and use a replicator to make several different copies. So first things first, we have to figure out a way to extract part of our map. So the way that I'm going to extract part of the map is first by using a select so that we can start to partition a little bit. I'll call this terrain generation. All right, so now we have, let's say, select terrain. We will need a threshold, and we'll actually need two thresholds. So one will be less, and we'll say less than 0.5, and then one will make greater, and we'll say greater than 0. And remember to pulse every once in a while because our displace feedback loop might be getting kind of stale. And what we'll do is use a multiply, or a comp if you prefer, to multiply these two things, and then we should be left with the portion of our image that is going to be between these two levels. So we have greater than this, less than this. Okay, so yeah, now we have our top, which is our threshold top, with less. And then we'll set that to 0 for this one, and then we'll have another one that's set to greater, and we'll set that to something greater than 0. And we'll multiply the two together, and that will give us this cross-section that we can then extract the edge from. So I'll create a null, I'll collapse these, we'll call this threshold between. We'll customize this component, and what we need is threshold low. So we'll grab the threshold for the low, and we'll grab the soften from the same. And then for the high threshold, we will again grab threshold. We'll label it threshold high, and we will grab the soften, and oops, I did that wrong. Drag and drop and set reference expression. And then we'll call this soften high. And just like that, we have a nice component that will help us to isolate different slices of our terrain. So now we can start to see how this may develop. Now, one thing is that we need to be able to restrict our jump flood just by this layer, right? We don't want to have the jump flood output that displayed across the entire texture. We want it just limited to the layer that we have. So we can use a composite and a select and do something like this and multiply those two together. And then we have this jump flood application that's limited just to the area that we're looking at. And if we throw an edge and comp over the input, change the pixel to 16-bit float, and then make the strength of the edge like more, we can see that now we're getting something pretty interesting, which is these geographically constrained areas that have through lines running that are kind of stretching perpendicular to the boundaries of the area. This looks to me a lot like roads, highways with shorter roads, smaller roads going out kind of to reach all of the more rural areas. Or you could think about it like river and tributaries, depending on which you are more interested in. So, that is one good thing. Another thing that we might want to do is be able to add some shading. So, what can I do? I can use a select. I can select the terrain. Then I can use a slope. Turn the slope monochrome using a monochrome, but maybe make the strength a lot more, like this. And then we can add the slope as well. And so now it's kind of hard to see at the moment, but I think will become easier to see in just a second. So let me drop an out down here, and then I'll point my viewer at our work in progress. Let me turn off the quantize for the value, and now we can see that hill shading a lot better. And so, yeah, if we take this out, you can see it without. We drop it back in, you can see it within. And that is pretty cool. So all I'm doing is really just taking the slope of the terrain that's fed through the displaced feedback loop, And then we're just using that as a proxy for elevation change, and then just taking the monochrome to apply it like a shading. And it really adds a lot, as you can see. Just having some of those striations and other layers going on adds a ton of complexity and makes things look pretty interesting. So, what else should we do? One thing that we can do is add a color. We can add color to our cross section by using a constant. And actually, at this point, it probably makes sense for me to drop down all of these things into another component so that we can start to make some parameters that we will then be able to use through our replicator. So I will call this map layer master. And then we'll customize this component, jump inside. First thing I'll do is drop the color. This will allow us to specify if we change to output and multiply. Yep. This will allow us to change the color of our cross section. Boom. Very easy. And then we may as well also parameterize our threshold here. So we'll set our reference here. Set reference. Just drag all these. This will allow us to establish our threshold from the parent component. Next, we want a little bit more sophisticated compositing. So I'm going to use a GLSL to do some of this instead. So I'm going to wire in our color. And then I'm going to wire in our edge. And then I'll wire in our slope to the GLSL multi. Give me a second for my text editor to come up. And where is it? Cancel. Okay, here we go. And we'll blow this up. And that's not what I need either. All right, so we will not, this won't be too bad, don't worry. So we're just gonna add a couple uniforms. Those will be hill shade, which we can add as a parameter as well. We'll just make that a float. Edges. All right, whoops. Edges here. We'll just call this edges. And then edge highlights is another one. And we will name this highlights. Okay, we can add them to our shader now. And the reason that I knew we would need those three, by the way, is because we know we're going to have our hill shade here. We're going to have our edges. And then I had knew from before that I'm going to want some highlights, which we will see why in a second. So uniform float hillshade, uniform float U edges, uniform float U edge highlights, and then we can get working on this. So first things first, we can just define our inputs. So we can define our jump flood input as 0. We can define our edge input 1, and we can define our slope input as 2. And for those who haven't seen this before, what this define does is essentially just set up a text replacement macro in the compiler. So anytime you write jump in the body, when the compiler is compiling the code, it will see jump and it will replace it with whatever this is. So this will just let us more easily change the input order if we need to, and is also more readable, I think. So I'll just name this J for jump. Read jump flood. Then we'll grab a couple other ones. We'll say our vec for E, and then I can just copy and paste this, change this to edge. Read edges. I'll paste it one more time, and this will be our vec for, we'll call it S, and that'll be our slope. Read slope for hillshade. Okay, so what do we need to do? We want to have the output start with the color selection, which is really the jump flood algorithm. I guess I probably shouldn't call that. Maybe we'll just call this color instead of jump. And I'll name this C. Okay, so we want to start with our color. We want that color to be multiplied by our edge. So we can say color is equal to our color multiplied by our edge, and we can see that that is indeed working. Let's clean some of this up, and I'll wire our DLSL in here so that we can see how this is working. Yeah, so now we are multiplying our color by our edge and outputting it. That is great, but I want to be able to control it a little bit more with my parent parameters. So what I'll do is actually say our color is equal to mix color times edge, and I will mix that by our U edges. And so now, as we change this edge value, our edge highlights will appear or not appear. Instead of having this just be called C, I'm going to create a new variable called mask for it. And then we can add our mask to our color. And then apply our hillshade. And we're going to do that in the same way. By mixing it with our hillshade. So now we can either add or not add the edges, add or not add the hillshade. So then all we need to do is add the highlights for the edges. So to do that, I'm actually going to turn off this comp over input. We don't really need that, but we do want the edges themselves. If we take out this, oops, sorry, we shouldn't do that. That will remove our edges. Oops. And yeah, so now we can also add our highlights a little bit better by using this, essentially just adding our mask back on itself again. What is this? U edge highlights is not assigned. Ah, that could explain it. So, yeah, now we can see there that we can add some highlights with our edges. And if we wanted to have the highlights be something more white, we could do this. We could say, instead of our mask being equal to this mix, we could say it's equal to, and then use a ternary expression, length of C, or actually no, length of edge. No, if the length of our color is greater than some small number like 1, then we can set our mask equal to a vec4 of 1, and if not, then we will set it equal to a vec4 of 0. Then there we go. Now we can see that we're getting now just white edges added to our map instead of the colored edges, and we can add back then our highlights. And so now we can turn our highlights up and down. We can turn our edges up and down, especially if we do this. I actually don't think we need that mix. Yeah, so that'll turn our edges off. Hillshade seems to be working. And we have highlights. All right, cool. So that gives us a lot of functionality. We don't actually need that mix. And yeah, so now we just have a simple little program to composite our different layers here. One other thing that we could do is just square the color before we start. It's probably less apparent with our highlights. Or, well, actually, I guess it's not doing anything because our color is just red. But I think if we make it something different, then yeah, we can see that this is essentially just converting it to an sRGB instead of an RGB, or you can think of it as like gamma correction. So if we wanted to also parameterize that, we could say gamma correct, make that a toggle. open our parent parameters. Oh, we already have that. Add U gamma to our shader, drag and drop that parameter on it, add it in here, uniform float U gamma, and then we can say if U gamma equals 1, then we will apply this gamma correct, and if not, we won't. And so now we can do that. Cool. So that is pretty much all the functionality we need from our shader. Get rid of this comp and move this down here. And so now we have a master component that will allow us to extract a layer based on our threshold, right? Which is pretty cool. And then color that layer. This constant should be pointed at our parameter. Assign its color, add some highlights, add some edges, add the hill shade, and we can even soften if we want, although I don't think that looks the best. So that is something great to start working with. Now, how do we use this to create multiple layers in a way that's not going to kill us with a ton of work? Thankfully, we have Replicator Replicator COMP. I keep messing that up. So if you go to the component dialog, Replicator, and just drop that down, what the Replicator does is take a base, or any operator really, as a master. So we'll drag that onto our master operator, and makes a bunch of copies. And then you can do different things with those copies and make them change different ways. A few techniques we'll look at in just a second. To essentially, just make a bunch of copies that are different in certain ways to build out more complex functionality that doesn't require a bunch of manual copy and pasting and changing of parameters. So let's look at this as an example. We'll change our replication method to number. The number of replicants, let's say 5 for now. And already we can see what's happening. So each of these bases is a separate slice. They're all pointed at the same slice at the moment because they're the same thresholds, but we can start to see the power. So I will delete those and do one thing here. So first, I'll make my operator prefix layer just to make things nice. You'll see that the grid or the replicants are always appearing at the same spot, specifically at the origin 0, 0. So I'm just going to move the rest of my stuff out of the way a little bit. And I'm going to change the replicator layout to vertical. So now everything's just going to be created vertically in a line right here, and I know it won't get in the way of the rest of my network. It's helpful that the replicated components are already connected to this input. That's great. So one cool technique when using the replicator is to use the digits that appear when you have copies of an operator with the same name and use those digits to run some parameters so that every replicant will have slightly different parameters based on the digits attached to it. So if we look at our terrain and hit N with the viewport open to see this normalized view, we can see that our terrain goes from values of 0.5-ish to 0.25-ish. Now, that may or may not always be the case. As you can see, I just re-hit pulse, and now we have from 0.8 to 2, 0.7 or so. So I'm going to start at 0, and we'll go up to something like maybe 3. So, for this, which I will give a digit of 0 so that it has a digit, we can set the threshold low to be 0, and the threshold high, let's just set to me.digits. Now we'll see that this is a 0. If we change the 0 to a 1, me.digits changes to 1. That is the case no matter what the digit is. If this is a 12, then me.digits is going to say 12. So I'm going to make this a 0 again. We can use that to calculate the top of our threshold range then by saying something like, okay, well, maybe it can be me.digits plus 0.5. And so then our threshold low will be 0, our threshold high will be 0.5. And if I copy and paste this, okay, well, our threshold low is still 0, but now our threshold top is 1.5. And so this is a different slice, or at least part of a different slice. So the number of replicants is going to be a function of how many slices we have, which is going to be a function of our step size. So I'm going to customize my parent component. We'll say layer step size. Make that a float. I'll default it to 0.5. I'm going to make the min something like 0.2. We don't want it to go too small, otherwise our replicator is going to try and make a bazillion replicants and crash our program. And we'll make the range max 3. I'm going to clamp the min at 0.2 as well because I really don't want a fat finger to crash our program. Okay, so now we have our layer step size. So we're going to want our low value to be our step size times me.digits. And then we'll do our step value times me.digits plus 1 for our top value. So now, if we change our step size, our threshold should change as well. And then I'll copy and paste this. Now we can see that our step size is changing. This is also changing. And we can see that now both of these sections are being altered as our layer step size is changing. Handy thing when working with replicators is that you can just hit recreate all, and any changes you made will be propagated. So if we make our layer smaller and then recreate, now we can see our different layers here are coming through. we want them to be different colors. So that's something that we should add. I'm going to go up to my, nope, I'll stay here. I'm going to add the color lovers picker palette, which I have mentioned before. You can grab this component from the forum. Should be pretty easy to find. Color lovers picker palette derivative forum, and you can just download this from here. I'm gonna grab this. This is actually the DAT. That's the ramp keys. So if we change this, our ramp changes. And then what I'm gonna do is name this null palette. And then in my master operator, I'm gonna make the color lookup from the palette. So, for example, op palette, and then if I want, say, row, this could be int me.digits +1, and then I'll want the column R. I said +1 because we have a header in our value 0. In case we have more digits than we have, rows, we'll want to loop. So we actually probably want to put this in parentheses and say modulo op palette dot num rows -1. So now in case our digits go above, we'll just be wrapping that around the number of colors in our palette so that we never run out. And then I'll just copy and paste this, changing to a G and changing to a B. So now we have this first color here is the color that this slice is going to be. If I recreate my operators, actually I'm just going to drag and drop this onto our master here so that we have it. We can see that these different colors are working. I'm not sure what's happening here though. So that would be 5. Okay. I think that because of this. Yeah. So I actually don't think I should have this -1 here because that is causing something to break. And I want my replicant suffix to start at 0. That way it will be 0 indexed, and that was what was causing our problem. So now if I grab a palette that has starkly different colors, maybe this one, you can see that the different palettes, I guess those colors aren't actually that different. You can see the different parts, different slices, each have their own color. If I have more slices, the colors wrap, although there's still a problem when we're trying to grab row 0. We basically don't want to grab row 0 because row 0 has RGB and not actual color values. So how do we fix that? We're grabbing row 0 because the modulus with this number of rows. I think we want this +1. to be outside of our modulo. Like this. Okay, maybe. Okay, I think this should be it. So let's see if this works. Me.digits modulo palette dot numbers -1. No. Okay. Why aren't you working? Modulo. Whoa, what happened? Okay, let's go back to here and work with our master. So me.digits modulo op palette.numbers -1. And we'll wrap that in an int. Why aren't we working? Aha. So, yeah, okay. Whew. Sorry about that. I forgot to have this +1. So basically, we're doing our digits modulo 1 less than the number of rows. So in this case, it'll be modulo 5 because that's the number of colors we have. So we're saying digits mod 5. But that can come back 0. And so then we want to add 1 to the result of the modulus so that we are then 1 indexing instead of 0 indexing, bringing us then to our first color instead of our row of RGB. So it's a little bit nuanced, but I forgot to have that little adjustment at the end, and that was what was giving us problems. So I think now if I recreate all of our operators, oh, whoops, I forgot to do this one. All right, now we recreate all of our operators and things are working. But how do we get everything all together? The easy way would be to do a composite and do something like add and then grab all these guys and wire them in, and then boom. I mean, it's looking pretty good, right? But how do we do that programmatically so that we, for example, if we have more or less replicants, have them all connect automatically? And how do we figure out how many replicants we actually need? So our number of replicants is going to be 3 because that's the height of our terrain, divided by our parents dot p dot par dot layer step size. So now that's programmatic. And the reason that I hard coded 3 is because I've worked with this terrain top a lot, and I know that it caps out around 3 all the time. You could, if you wanted to, do something like an analyze, and then max, and then chop 2, and then use this if you want, divided by me parent dot p dot par dot layer step size. That is also possible, but frankly, I don't think it's worth the extra overhead. So I'm just gonna hard code that to a 3. But worth knowing in case it's more important to you to be able to do that. So now, answer the question, how do we connect everything? We can use our replicator callbacks and the connector class to use Python to make those connections for us automatically. So very simply, for C in new ops, we can get rid of all of this, and we can say C dot op, and we want the out operator from that component. Then we'll use this syntax here, dot output connectors, and we want the first one, and then we will connect it with dot connect, and we'll point it towards this comp, which I will call aggregate to make it easy. So then we'll just connect it to our op aggregate like that, and we'll see if it works. And just like that, all of these operators are being connected to our aggregate operator automatically as they're being created. Replicator callbacks like this are super, super handy. So this is just one easy example of how to use them, but you can, I'm sure, imagine the depth that you can get to in them. So now we have this dynamic set of layers. And I'm just going to use Alt-N, create a null after my aggregate. And I'm going to select all of this. Actually, I'm going to first use the right click to add a null in front of my select terrain. I'm going to make sure in my master operator, since I noticed that the select terrain was still pointing at the master operator here, that's because I copy and pasted that select at one point. So I'm just going to go in and point this select inside of my master layer to the input so that we don't have that link anymore. And I'll recreate. And now, as we can see, we don't have those links, which means I can now highlight all of these, collapse them, and then I'll call this base layers. And if we click on some different colors, we can start to see our work paying off. So we have these really cool partition spaces that each have their little roads kind of going through. Our palette is dynamic and lets us choose what color we want each of them to be. And if we change things like our layer step size, we will see all of this change as well. In addition, if we quantize things, we will also see all of this change. So now you can already see some of the pretty complex effects getting built up. And yeah, this has been pretty short so far, and we're already generating some pretty cool stuff with it. So this is going to be the end of this tutorial. Next, we will take these layers, we'll add some post, we'll add some final compositing, and just kind of wrap things up. Thank you to all of my Patreons. As always, you guys really keep me going. The financial support is making a huge difference for my ability to just keep pursuing this artistic dream of mine. And for that, I really can't thank anyone enough. So, thank you, and until next time.